Hey guys, in today's video I'm going to be teaching you how to divide algebraic terms. This is the last learning task and hence YouTube video for term 3. That's right, we're almost there. This one is actually quite a good learning task because it's kind of a recap of the index laws that we have already touched on together, half being at school and the other half being done remotely. But this learning task specifically focuses on the second index law, which we did do at school together. So not really any new information here, it's just a recap. So let's get into it. And by the way, all the questions that I'm going through today, I'll segment them in the description so you can skip if you want to, but they're all direct questions which you'll find in the learning task. Okay, so they're quite specific. Now, question 1, simplify. CD divide by C. Now, for me personally, and what I encourage you guys to do is when you see a question written down like this, all on the one line and the actual division sign written like so, I want you to rewrite it because it's easier for you to visualize that it actually is a division. And I want you to write it in this form like this. So with a line in between like so. So this would change to CD divided by C. Okay, so that actually equals the exact same as this. Now, this is a lot easier for me to visualize what is happening. So CD is being divided by just a C by itself. Now, the way that we simplify this is anything that is the same in terms of letters, okay, or in other in other words, pronumerals. I'll just say letters for now though. Any letters that are the exact same on the top and the bottom can be immediately cancelled out. Okay. Now what I mean by top and bottom, it means, so this line here that's showing us this is a division, whatever is on top of it, if there is a letter that is exactly the same as another one below it, you can cross them out, okay? Because anything divided by itself always equals 1. What's 2 divided by 2? 1. What's 10 divided by 10? 1. What's 200 divided by 200? 1. What's 1 million divided by 1 million? 1. Anything divided by itself cancels each other out, okay? So what I can go ahead and do here is, because I have a C up on top and a C down below, I can go ahead and cancel them out. So I'm left with my answer, which is D. Okay, so that is literally my answer. This is the simplified version of this. Okay, so let's practice but go one step further with the next question. Now this time, not only do we have letters, we also have numbers. Now you can actually kind of treat the numbers differently to the letters in this case. So I'm just going to cover the letters for now so we don't get confused. And we have a 24 divided by 16. Now you need to find what the highest common factor is of these two numbers. So HCF which stands for highest common factor, basically means what is the largest number that can go into both of these numbers evenly with no remainders. Okay? What number, think of the largest number that you can that will go into these two numbers evenly with no remainders. Okay, it's going to be one number, and then we'll use that number to then go ahead and simplify. So maybe over here to the side, I'll just do a list of actual numbers that go into both 24 and 16. Okay, let's start with 24. What numbers go into 24? Well, 1 and 24. We have 2 and 12. We have 3 and 8. Can we think of anything else? There's 6 and 4. Okay, there's actually quite a few numbers. All right, now let's do the same for 16. We've got 1 and 16, 2 and 8, and then 4. Okay, now we need to find the highest number, so the greatest number, the biggest number that goes into both of these numbers. Now, 1 and 1 both go in. Let's see if we can find a bigger number that's on both sides. 2 and 2, well, that's bigger and it's on both sides. Can we find anything else? Well, 24 doesn't go here, 12 doesn't go there, 3 doesn't go here, 8, there we go, there's one. We'll just keep that in mind. 6, well, 6 doesn't go into this. 4 goes in, but we found 8, which was bigger. So since 8 goes into both 24 and 16 and is the largest number out of all of them on both sides that do go into both numbers, that is going to be our highest common factor. Okay, so our highest common factor equals 8. Now, if you chose the 1, the 2, or the 4, you also would kind of be right. Like, you'd still be simplifying, but the only thing is that when you reach an answer, you'll have to keep on simplifying these numbers until you get an even lower number. So you're kind of adding more work. Whereas if we find the biggest numbers straight away, we can get straight to the most simplified answer for both these numbers. Now, because we know that our HCF is 8, again, I'm just going to cover the letters. Now, let's deal with the 24 first because that's on top. 8 goes into 24 3 times. So we cross that out and we write a 3. Okay. 8 goes into 16 twice. So we cross that out and we write a 2. Now we cannot simplify any further. There are no numbers that go into 3 and 2 with no remainders. There are none. Okay, so we know that we've simplified as far as we can go. Okay, now we can actually rewrite this so it looks a little bit neater. So I'll rewrite. We have 3WZ on 2Z. Now our numbers have been dealt with. Now it's time to deal with the letters. Well, what did I say up here? Any letter that is on the top and the bottom can be crossed out because a number divided by itself always equals 1. So whatever you find up the top that's down the bottom as well, or whatever's down the bottom that's at the top as well, you can actually go ahead and cross them out. So you can see we have a W up top, but no W down the bottom, so that has to stay. We have a Z over here up the top and another Z down the bottom, which means because there's a Z up here and a Z down there, we can go ahead and cross them out. Okay, because anything divided by itself equals 1. Now, that's our answer. (3W on 2 is our answer. Okay. Now, we're moving on to the index laws questions. These should be revision for you guys. Okay. Remember, when we divide and we're using index laws, we are referring to the second index law. We have 6 altogether that I've taught you. All right. And dividing is the second index law. If you need to go back on your notes, which should be in your exercise book from work that I've written on the board, then please do so, all right, if what I'm going over now doesn't make sense, okay? So, when we are dividing, the powers get subtracted. So, I'll show you the expanded form of how to work this out, and then I'll show you using index laws. Now, this is the same as that. That's the exact same thing. So what this is saying is there are 5 letter A's up here. Five letter A's. 1, 2, 3, 4, 5. And those 5 letter A's are being divided by 3 letter A's. Okay. Now, if we go ahead and do what I told you to do in question 1, where if you find a letter up the top and it's also down the bottom, you can cross them both out, we can get rid of some of these A's up the top or down the bottom, okay? And you basically keep on crossing out until you're left with nothing on either the top or the bottom. So, we'll start up here. A up the top, A down the bottom. A up the top, A down the bottom. A up the top, A down the bottom. Now we have no more A's down here, okay? So we can't cross out anything else down here because there's nothing left. Nothing exists anymore down here. All we're left with are 2 A's up the top. So our answer is A times A. Now, you could leave your answer like this if you wanted to. I mean, you're technically not wrong, but your answer should be in index form. So instead of A times A, you would write A squared, A to the power of 2, because you have 2 A's. 1, 2. Okay? Now, if we just simply used index laws and we knew that the second index law stated that when you're dividing 2 things, the powers get subtracted, all you would do is do this. There's literally 2 steps. Okay? And you still get the same answer. Let's try with this one here. Again, you have to look at the numbers separately to the letters. All right? So let's just cover these for the moment. We have a 10 up top and a 2 down the bottom. What is our HCF? All right, what is the largest number that can evenly go into the numbers 2 and 10? Well, 2. This one's actually quite a simple one, okay, because the only numbers that go into 2 are 1 and 2. All right, so the HCF is 2. Now, how many times can 2 go into 10? 5. So cross it out and write 5. How many times does 2 go into 2? Once. Okay, so now we're left with now you guys know that the 1 doesn't actually even need to be there. All right, I could have just not written it, but I'll write it there for the purpose of showing you how I simplified. Now again, in expanded form, like this is what this fraction looks like. We have a 5 and we have 6 C's. So 1, 2, 3, 4, 5, 6. Okay, we have 6 C's and 1 5. Down the bottom, we have the number 1 and 2 C's. So keep on simplifying the letters that are up the top and down the bottom until you're left with none on either the top or the bottom. Okay? Remember, we can't do the numbers because we already dealt with that. They can't be simplified any further. So 1 C up the top, 1 C down the bottom, 1 C up the top, 1 C down the bottom. We're left with no other C's down here. So we're left with 5 and 1, 2, 3, 4 C's divided by 1, but you actually don't even need that in your answer. So the answer is 5, C4. How could we have done that in probably less than half the amount of time it took to do that? Well, we've already done our HCF part. We know that it's 5 divided by 1. If we used our index laws, we could have gone 5, C, 6 minus 2, which equals that. Again, 2 steps, that's it. Okay. Last one. I'll show you using index laws. So we have H's and J's. Now, let's deal with the H's first. We've got H7, H to the power of 7, divided by H to the power of 4. So write your big H, and you have 7 minus 4. Followed by your J's. Now, if there's no number to the power of a pronumeral, it's an imaginary 1. So I'm going to go ahead and put a 1 there. I'll just cover that. So then we've got J, 2 minus 1. So my answer is H. 7 minus 4 is 3. 2 minus 1 is 1. But I told you that you don't need to put a 1 to the power. So my answer would be H3J.